In this lesson, we will delve into the application of key object-oriented principles in C#. Understanding these concepts is crucial for developing robust and scalable applications. We will cover encapsulation, inheritance, polymorphism, and abstraction through practical examples that reinforce these principles. Don't worry if this feels new at first. Now, encapsulation is the principle of bundling the data, attributes, and methods, functions, that operate on the data into a single unit known as a class. It restricts direct access to some of an object's components and can prevent the accidental modification of data. This is achieved using access modifiers. In C#, access modifiers include public, private, protected, and internal. Here's a simple example. This slide introduces a class definition. Study the structure in the code sample. In this bank account class, the balance field is private, meaning it can't be accessed directly from outside the class. Instead, we provide public methods to allow controlled access to the balance, demonstrating encapsulation. Inheritance allows a class to inherit properties and methods from another class. This promotes code reusability and establishes a natural hierarchy between classes. In C#, you can create a derived class that extends a base class. Consider the following example where we have a base class animal and a derived class dog. Review the class shown on screen and how its members are organized. In this example, dog inherits from animal. This means that a dog object can call the eat method, demonstrating inheritance. Here's the idea: polymorphism allows objects of different types to be treated as objects of a common supertype. It's mainly implemented through method overriding and interfaces in C#. Method overriding occurs when a derived class provides a specific implementation of a method that's already defined in its base class. Here's a simple example using method overriding. This slide introduces a class definition. Study the structure in the code sample. In this case, the speak method is overridden in the cat class, allowing us to call the method on an animal reference and get the behavior specific to cat. Now, abstraction is the concept of hiding the complex reality while exposing only the necessary parts. In C#, abstraction can be achieved using abstract classes and interfaces. An abstract class can't be instantiated and can contain both abstract methods without implementation and concrete methods with implementation. Here is an example of an abstract class. This slide introduces a class definition. Study the structure in the code sample. In this example, the shape class is abstract and contains an abstract method area. The circle class implements the area method, providing specific functionality while adhering to the abstraction principle. In this lesson, we explored the key object-oriented principles of encapsulation, inheritance, polymorphism, and abstraction in C#. These principles are foundational for creating well-structured and maintainable code. Through practical examples, we illustrated how to implement these concepts in your C# applications. Now put what you've learned into practice. First, create a class representing a car that has properties for make, model, and year. Include a method to display the car's details. Also, extend the car class to create an electric car class that adds a property for battery capacity and overrides a method to display details specific to electric cars. Finally, implement an abstract class employee with an abstract method calculate salary. Create derived classes full-time employee and part-time employee that implement this method.